Okay, guys, today should be Wednesday, um, April the 22nd. We're going to do a lesson today on the volume of prisms. Hadn't had a lesson in a while. I've been doing just a lesson and giving you a lot of days to work on stuff, so this is new material. This is actually in our curriculum, so this is an important one today. So the lesson title will be Volume of Prisms, and day is 4/22. Okay. So just understanding prisms to start with, these are going to be your three-dimensional shapes, your boxes, your triangular prisms. I mean, by definition, they have to have two parallel congruent faces that are connected by rectangles. Okay. Um, so there's, a couple of types that we're going to really focus on today, and go through those. We'll do your boxes first. I'd be surprised if you hadn't had some of this before. So, for example, we'll do rectangular prisms first. So, a lot of times the challenge here is trying to draw these shapes and, copying them like I'm trying to draw them. In class, we've drawn some of these before. So, I know some of y'all really struggle on just a drawing of them. And even me, you guys are watching me draw the shape. It may be harder for you to see what I want you to see here. So, hopefully, you'll get the picture. I will say the first ones, we're just going to be drawing a box, okay? And so, for example, this prism, it's even extra hard here with this tablet, so just bear with me. All right, there's my box, rectangular prism. It's got rectangles that are parallel and congruent, and it's connected by rectangles. So basically, all six faces are rectangles here. The volume of this thing would be the amount that it holds, right? How much can fit inside, the amount of space available inside the shape. The formula for this is going to be volume equals to its length times width times height. You guys have done this one before. It doesn't really matter what you call the length, width, and height because you can rotate and turn your shape any direction. So it's not really important which one of these numbers go first in the formula. In this particular problem, I will say that the length is down here on the bottom and the width is on the side of the bottom and the height's distance from the bottom to the top. So height would be here. Doesn't have to be that way. Just kind of, the way I did it in this problem. So for this problem, let me give you some dimensions. Let's say that the length on the bottom equals to maybe 5. The width on the bottom equals to 3. And we'll say the height equals to 4. Meters, inches, miles, yards, whatever units you guys, whatever they give you. So this is going to be a calculator problem. Have your calculator beside you when you're working these problems. If you don't have it, you may want to grab it real fast. So for me, this volume is going to equal to 5 times 3 times 4. We put that in the calculator. I think we're getting 60. Volume equals 60. Okay, your units would be like meters cubed, yards cubed, whatever cubic unit. So we're talking about the number of cubes that fits inside. So just kind of for example here, just to make sure you really understand. If this is 5 inches, 3 inches, and 4 inches, all the units have to be the same measure. Then that's the length of the size. Then what you're actually finding is the number of little small cubes here, about the size of a dice, with 1 inch on each side. That little cube is a cubic unit and a cubic inch. And we're finding how many of those cubic inches it would fit inside this box. The answer would be 60 cubic inches, inches to the third power, if you could see that. So, when you find the volume, length, width, and height, you're actually finding the number of cubes it takes to fill up the space. And in this problem, we're talking about cubic inches. And the cubic inch, like I said, it's about the size of a dice that you play a game with. All right. Next shape, a little bit harder. Um, I think the drawing's tough on these. I'm going to draw this shape to be like a wedge, like a piece of cake or something. But there's a triangle on the top, okay? And there's going to be an identical triangle on the bottom, so a congruent triangle on the bottom, right? So it looks like that. I'll include the dotted line here, which is representative of an edge that you can't see from your view. And that's kind of the shape that we've got. So this is a triangular prism. All right, so let me kind of back up. There's one big general formula for all prisms, and this is what it is. The area equals, volume is what I'm supposed to be doing. Volume equals capital B little h, right? Capital B stands for the area of the base. Area of the base. Of course, the height, H stands for the height of the shape. So we just got through doing your, I'm going to flip back here for a minute. I thought I would. Okay, we just got through doing a rectangular prism. The base of this shape is that bottom rectangle. You can't really see it, but it's down on the bottom. It's the part that's sitting down here on the bottom. It would be kind of like this rectangle that I'm making in red right now. That's the base. Okay, so if you find the area of that rectangle, which is 5 times 3, that would be capital B in my formula. And then times the height would be the 4. So it's the rectangle times the height. The bottom rectangle times the height. It's the formula, length times width times height. I know I'm making this more complicated. You guys just like to do length times width times height, but it really will explain this one a little bit better. Make it easier for you to understand this formula. So for this problem, for triangular prism, if we do capital B, which is the area of the bottom, well, that's a triangle, right? So this triangle right here in red, we have to find the area of that shape. The area of that shape is going to be 1/2 times base times height, because that's the area of a triangle. The next thing we do is multiply this by another height. Well, this height's going to be, I'll do this in blue, the distance between the two triangles, okay? So I'm going to put some numbers here, see if we can find the right numbers to use for this formula. I'll go back to black here. So I'm going to try to make this a little bit easier. I'm going to do on the bottom, I'm going to do everything on the bottom triangles, which makes it harder for me, but it's going to make it easier for you. So let's say that that bottom triangle has a dotted line here, which is a height. I'm working on the height of that triangle now. Let's say that that height's 8, okay? That's not 18, it's just 8. And let's say the base of the triangle, which would be this line across the back, would be a 10, right? So right now, we're doing 1/2 times 10 times 8. That's the area for the bottom red triangle. Now I've got to do times the height of the whole shape, the height of the whole prism, which is the blue line. Let's call it 12, okay? So times 12. So we're going to want to grab our calculators. We're going to type in 1/2 times 10 times 8 times 12. I think that's giving us 480. So volume equals to 480. Again, this is number of cubes it takes to fill this up. Cubic inches, meters, miles, yards, whatever. But it's the number of cubes that fit inside of this. Okay. Well, this time you might say, well, you can't fit cubes inside of a triangle or a triangular prism. Then you could think of it this way. If my answer is 480, then you could take 480 cubes worth of water, or you could fill up a cube 480 times and pour it into the shape, and it would fill up exactly to the top with the water. Okay? 480 is our answer for this one. We'll do another one of those. This time we'll draw our triangular prism kind of laying down. You can almost imagine this like a tent, a little tent that you would go camping in. Right, there it is. We'll even put the zipper right here on the front, the door. so you can really see what's going on. Um, okay, so we have this triangle, looks like a tent. I got to give you some dimensions here. Remember, our formula we're using here, V equals capital B little h. B this time is a triangle. So we're doing a triangular prism. 1/2 times base times height. That's your capital B. That's the area of a triangle. Times the height of the whole prism. Those two heights are going to be different dimensions, different numbers, normally different numbers. So let's talk about the triangle first. The triangle in this problem is not on the bottom, right? Because we flipped this shape. So the base triangle, I'm going to actually say, will be this red triangle right here, right? Remember, a prism has two parallel congruent bases. In this problem, the front triangle and the back triangle are the bases. I've got to get the area for one of those triangles. Let's call the bottom of this thing 6. The height of it's going to be, I like to use even numbers. It makes it easier for me. So we'll say it's 8. I know that's too much, but we'll call it 8. So we know that the base and the height in here is connected with a right angle mark. Always look for right angle marks. So we got 1/2 times the 6 times the 8. All right, that's going to be 24. To make this easy, let's just say that the height of it, now watch where I put the height of this thing. See this blue line? If this were a tent, that'd be the distance from the front of it to the back of it. That blue line is going to be your height for this prism. The height of the prism is 10, right? It's the distance between the front and the back triangles. So 10 is going to be my height of the prism. Again, it's the part that's actually on the ground, it's the distance between the triangles. Multiply it together on the calculator, we're going to get 240. Again, this is cubic units, cubic meters, miles, yards, inches, feet, whatever. Okay. That's the only two type of problems that you guys are going to be doing for homework. This is just an introduction to the volume of prisms, and just kind of showing you different ways that they look. You're going to do boxes, and you're going to do these triangular prisms. So to review, today we use two different formulas. If you have a box or a rectangular prism, that's an R. Use the old-fashioned formula V equals LWH, right? Volume equals length times width times height. If you have a triangular prism, use the formula 1/2 base height, which is the area of your base triangle, then times the height, that's multiplication sign, times the height of the whole prism. Okay, so you have two formulas to use. I think for homework I gave you 6 problems. You will probably have 3 rectangular prisms and 3 triangular prisms. So take your time, go slow on these. I will go over these in detail tomorrow and show you all the numbers that you should have put in. Use a calculator to get the answers. Okay?